Right, let's work with an isosceles triangle here. Isosceles means that two of the sides are equal. So that's what these tick marks indicate, meaning this is 13, and so this must be 13 as well. And here I have a 10. What does it indicate? Well, it's written in the center of the line, so this line is 10 units long. And there's a dash through the center. Suppose the question is, tall is this triangle? And mathematically, they would say something like, what's the altitude of this triangle? Or maybe they'll just put a variable there and say solve for that variable. So let's put a little x. What's going on is if you kind of focus on part of the triangle, you will notice there's a right triangle here. That's because of this right angle here. Why is that significant? Well, a right triangle, you can use Pythagorean theorem. So remember that is the leg squared plus the leg squared equals the hypotenuse squared. Well, this from here to here is one of the legs. And this line in the center is the other leg. And this 13 will be the hypotenuse. Let's go ahead and put the information in to the Pythagorean theorem. So this leg, now here's a little trap. It's a tricky thing. Some people would look at this and they would put a 10, but it's not 10, is it? The leg of the right triangle is really only half of that. It's 5 units. So we're going to put a 5 here. And then the leg here is unknown. That's our variable. And the hypotenuse is 13. So you're plugging in the information into the Pythagorean theorem. And now you can solve. So 5 squared, x squared, we don't know what that is. 13 squared is 169. Trying to get x squared by itself, let's take away this 25 from both sides of the equation, bring down the results, and our last step to get x by itself, we need to get rid of this little square. So let's take the square root, both sides. So x equals whatever the square root of 144 is. X equals 12. So looking at the triangle over here, we see that x equals 12. The height of the triangle is 12.